Over the weekend I took part in the Ludum Dare 54 game jam where the theme was limited space. I thought it would be fun to try to create the Risk board game in PyGame, as it would be cool to work with geographical data as well as trying to code some strategy AI. Despite some obvious flaws in the gameplay and the AI, I'm quite happy with how it turned out, and seeing as the codebase was fairly small, I thought it might be useful if I did a small tutorial series on how I made it. Okay, so in this first part we're going to be setting up the project and installing any dependencies. I'm going to be using Visual Studio Code. My Python version is 3.8.2. So yeah, let's get started. So the first thing we're going to do is open up a new terminal. My default terminal is git bash, but other terminals should also work. We're going to be installing our dependencies inside a virtual environment. It's generally good practice. So I'm creating mine like this. If you're on Mac, venv should also work. Then I'm going to activate this virtual environment. So that's for Windows, it's inside env scripts, and then there's an activate.bat file to run. Yep, and that should have worked. So now if I just check, so this should be completely empty. Pip freeze should return nothing. Good. Okay. So the first package we're going to install is PyGame, because this is how we're going to be rendering everything and how we're going to be kind of creating the game. So I'm going to do pip install PyGame and just let that install. The second thing we're going to install is the package for working with geographical data. So the one we're going to be using is called GeoPandas. So I'm going to do pip install GeoPandas, and I believe that should also install NumPy and pandas along with it. So this might take a couple of minutes. Okay, so I'm just going to see what's been installed so far. Okay, that looks good. We have our PyGame. Pandas is going to be useful. NumPy is going to be useful, and we also need GeoPandas. The last thing Shapely is also very important. The last thing I'm going to install is the IPy kernel. For cleaning this geographical data, I'm going to be using a Jupyter notebook inside of Visual Studio Code. So I'm also going to install that. So like this. Okay, so that's finished installing. Now what I'm going to do is just a quick check that our virtual environment is working, and also that we can run some code in a Jupyter notebook. So I'm going to close the terminal. I'm going to go over here. I'm going to create a new script. We're going to call this clean geodata. I'm going to make this have a notebook extension, so IPyNB. I'm going to create this. So that is now starting. I'm just going to go over here to make sure that we are using the correct Python environment, and it looks like we are. It's kind of already automatically found that we want to be using the Python executable within this virtual environment, so that's great. So now if I start typing, hopefully it should be able to detect that we have GeoPandas, which it has. So import GeoPandas as GPD. Hopefully this can be imported fine with no problems, and it looks like it has. I'm just going to do a very quick check. Okay, and it also seems like our Jupyter notebook is working correctly as it's returning output. Okay, great. So the next thing we're going to do is to download some of the geographical data that we want to work with. So the dataset we're going to be using for this project is this countries data, which you can find at this URL. I will include a link to this website in the video's description. So yeah, this dataset contains all of the countries in the world, and very crucially for us, it contains the boundary coordinate positions of these countries. So this is precisely what we're going to be used to kind of create polygons that represent these countries and data that we can work with within the game. So from this website, all you need to do is click on download countries, and this will download a zip file into your downloads. So now returning back to our project back in Visual Studio Code, what I've done is I've created a new folder called data, and inside that folder is basically the extracted zip package that we just downloaded. So this is where all the data is that we will be using. The only file from this is this .shp, so this shape file. Okay. From here, we're going to import the shape file using GeoPandas and then start to clean the data so that we can use it within our game. So the first thing we're going to do is define so geodata equals gpd.read file. We're then going to supply it the file path to our shapefile. So very useful in VS Code. It kind of helps you navigate your folders. So we've put ours inside of data, this admin countries folder. Unfortunately, we can't see all the extensions, but so let's just guess. Okay, did not guess correctly, but any of them will do. We just need to change the extension to the shapefile because that's the only one we're interested in. So let's return this and see what we get. Okay, so that has worked. This I believe is it's a geo data frame, so not quite a pandas data frame, but a data frame of some sort. But we can use the head method to just take a look at what we have. And yeah, so we can see some geographical data. And so there's quite a few columns, 169. Don't know exactly what all of them do, but we're only going to be using 3 of these columns. So I'm just going to define a new variable called columns. In this, we will put admin, because to me that looked like what the name of the country is. We're also going to be extracting the continent, and then finally the column that we need to use is country. So that contains all of the geographical locations of the borders. So we can take these columns, again, just gonna kind of subset our data frame and take a look. Okay, yeah. So this is all we need. So we have country, continent, and the geometry. Next thing we're going to be doing is to kind of clean up this data within the geometry column. Actually, before we start cleaning up the geometry data, I'm just going to take a look at what countries we actually have in this data set. So if I do geodata admin unique, we can take a look here. I'm only doing this. Actually, before I do that, I want to take the European subset. So I can do this, and then this should work. Let's have a look. Yeah, okay. So this has now returned all the countries that have this continent equals Europe. Now, I'm not sure if I want to use all of these countries because it does contain some kind of technical countries that are so small that they're really not going to be very visible on a kind of game map, and it's just going to be difficult to work with. So I'm talking about countries like the Vatican in Rome or Monaco in France. You know, we're not that interested in including these countries. So before we start cleaning up the geometry data, I'm going to create a list of countries to basically remove because yeah, we don't want to work with them. So creating another variable, this one is going to be the remove list, and in it we're going to include all the names of the countries that we don't want to work with. So we can just kind of go through them. Vatican, nope. Jersey and Guernsey, and probably Isle of Man, kind of too small. What else? Ukraine, Switzerland, Sweden, Spain, Slovakia, Slovenia, San Marino, a very small place in Italy. Russia, okay, basically going to be like too big. If we kind of want to focus on Europe, having Russia involved, it just increases the size of the world map, and only a small part of it kind of borders Europe. So I'm just going to take it out for that reason. Romania, Portugal, Norway, Netherlands, Montenegro, Moldova, Monaco, going to remove. Liechtenstein, sorry, you're not making the cut. What else? Latvia, Kosovo, Italy, Ireland, Hungary, Germany. I have no idea what this is, but I'm taking it up. Faroe Islands, yeah, so it's kind of small islands, collection of islands we're going to remove. Denmark, Czech, Croatia, Bulgaria, Bosnia, Belgium, Belarus, Austria, and Andorra, also very small. Alright, so for now we're going to just have this as our remove list. You know, we can come back to this in the future, either add countries to the remove list or remove them from the remove list, but this is what I'm going to be working with now. Okay, so from here we can start iterating through our geo data frame, and we can start creating cleaned geometry coordinates from the geometry column. So I'm going to iterate over the data frame, and we can use the pandas method here. So for idx row in geodata.iterRows, so this is going to, for each kind of iteration, it's going to return the index of that row, also the row itself and the values. Actually here I'm going to subset it because, as I said before, we're only going to be working with countries within Europe, and we're not going to be working with countries that are included in this remove list. So here we can do geocontinent equals Europe, just like I did before, and then we also want to say geodata.admin.isin. We're going to supply it the list. So actually we want the inverse of this, because if this returns us all the countries that are within this remove list, then we basically want the opposite of that. So to do that in pandas, we just supply the tilde here, and that should work. Let's just have a look and see if this has returned the kind of countries that we're after. And looks good to me. So these are all European countries, and I cannot see any of the countries that we included in the remove list. Okay, good. Okay, from here we're going to start extracting the coordinates from the geometry column. To do this, we're going to import a function from the Shapely package. So from shapely.geometry import mapping. So here I'm going to call this object geojson.obj, and we're going to use this new mapping function, and inside we're going to supply it the geometry from each row. Here then I can basically, inside this object there will be some element called coordinates, which we're going to access. So we're going to take this, then going to look for the coordinates to extract. The next thing that we have to do here is that some countries, as you may have seen from the original data, are multi-polygons rather than polygons. So I think these are countries where the geometry of the boundaries is not necessarily like one single polygon. Maybe there are kind of different land masses associated with the country. So that's a slight complication for us. Basically what I did is I'm just going to look for the polygon with the largest number of coordinates and kind of assume that this is the main landmass of that country. So other implementations are possible, probably better ones, but I'm trying to keep it simple, so this is what I went with. So first I'm going to iterate through the different potential polygons and look for the polygon with the largest number of points. So I'm going to import NumPy for this. So import NumPy as np. I'm going to go back. We're looking for argmax. Here we're going to basically return the length of each chords. So how does this go? So 4 chords in geochords. I'm just going to create a new dictionary for storing all of these things. So I'm going to call this country chords. And how I'm going to save the data is, firstly, the key of this dictionary is going to be the name of the country, which is from the admin column, and then the value in this dictionary is going to be the geochords, and we're taking the largest index. So I'm going to remove the print statement, run this code. Okay, it's worked, and I'm just going to kind of print this. And it looks a bit cleaner, so we have this kind of new dictionary now where we can take a key, for example, United Kingdom, and it seems to have a load of kind of coordinate positions. The final thing we're going to do before saving this data is, for some reason, a lot of this data is kind of nested at different levels. I'm not entirely sure why that is, but what I did seemed to work, so I'm going to continue going with it. So I'm going to create a new dictionary just called countries. This is going to be the last kind of data object that we create before saving this data. I'm then going to iterate through the maybe call this chord. Iterate through the dictionary that we just created, and then I'm going to say while the length of country chord is less than 5. Yeah, I don't have a good explanation for why this works. I just tried it and it seemed to work. I'm then going to kind of repeatedly take the first index to kind of reduce the whole nesting, and then I'm going to save it again. So country name, equals country chord. So I've got this new object called countries. Just going to take a quick look at it. Okay, finally, we're going to save this data, this kind of cleaned geometry data, as a JSON file. So I'm going to import JSON, and here I'm going to do with open, and we are going to call this country chords. Let's just do that, .json. We're writing it, so then we just do json.dump, name of the object, which is countries, and attach to this file. Okay, so let's run that. If we then go to our folders, we can see that we have this kind of cleaned geometry data, which we can now use to create our game. Now that we have our clean data, we can start to create a basic game. So I'm going to close these two windows. I'm going to minimize this. I'm going to create a main PyScript. So this is going to be the entry point of our game. And I'm going to start importing stuff. So we're going to require PyGame. We're going to initialize PyGame. I'm just going to also initialize the music mixer. We won't need this for now, but later it might be useful. And also font. Going to define the dimensions of our game window. So I'm going to use width of 1280 and height of 720. Then I'm going to create a window size. So I'm going to use vector2 for this, so we can call this width for the first argument and height for the second argument. I'm going to create our game screen, so this is pygame.display.setMode, and we can feed it the window size. I'm going to initialize our clock to control the frame rate, etc. And I am going to set a caption of the window, so I'm going to call this risk. From here, I'm going to do just some create game here, and then game.quit. And I normally use system.exit, so I'm going to include system here. This is just black for formatting Python code. I generally use it, so not necessary though. And sys.exit. We can create our game class. So I'm going to create a new folder. I'm going to call this source. Inside source, I'm going to create a new Python file called game.py. Again, I'm going to import PyGame. I'm going to call this class game. I'm going to create the init method. Here I'm going to pass it all of the kind of arguments, or all of the objects that we created in the entry points that we need for our game. So this is going to be the window. So I'm going to call this screen. Also the clock, which is a pg.time.clock, and then our window size was a vector 2. I'm going to save these things within the class. So that's the screen, the clock, and the window size. After that, I'm going to start writing some of the methods of the game. So the one that we're going to be using inside the main script is run. So this is going to, and yeah, also here we're going to have a self.playing equals true, because we're going to use this in the run loop. So I'm going to say while self.playing. Now we need to create some methods to run within the run method. So we want events, and I basically copy this kind of template for all of my Python games. Have events, I have an update method for updating the game, and we're going to have a draw. Okay, so in our, going back to our run method, first thing I'm going to do is just update the clock. So we can do self.clock.tick, and with the frame rate, we're going to use 60 frames per second. Then we need to, on each iteration within our game loop, we need to kind of clear the screen again. So do self.screen.fill, and I'm just going to make it black for now. We have all of our methods, so events. This is going to be primarily for detecting when we want to close the game. Then we have our update, and then we have our draw, and finally we need to update the screen with everything that we've done. So to do that, we do pygame.display.update. So inside of main, I'm going to import this game class. So from source.game, import game. We're going to do game equals game, and we're going to feed it these things. There we go. And then we're going to run the game. So basically, when the game, when self.playing is false, this run method will end, and we exit cleanly from the program. Right now we actually haven't programmed any way of ending the game, so this is precisely what we need to do now. So we're within the events method, so for event in pygame.event.get, if the event.type is p.quit, so that is if we like kind of click close on the window, we can say self.playing equals false, which will mean that we will exit from this while loop. Another way that I generally like to exit is if we press the escape key. So to do that, we're going to do event.type equals pg.keyDown, event.key equals pygame.escape. Okay, and so that's going to be our second way of quitting the game. That looks okay so far, so I guess we can try it out. There we go, we've got our black screen, and hopefully this will exit it. Good, okay, that's worked. So to wrap up this episode, the last thing we're going to do is to take our cleaned geometry data, and we're going to try to use that to render a map of Europe using PyGame. So going to the source folder, creating a new script called Geo. Inside Geo, I'm going to import JSON because we're going to import the data that we just saved, and also import PyGame. I'm going to define two classes. So first is the country class, and this is just going to be a container for some data that we want to define as being part of a country. So we're going to give the country a name, and we're also going to give it its boundary coordinate list. So I'm not going to do anything now apart from just save these two things. And I'm also going to give it an empty draw method because we will be drawing these countries to the screen. So I'm going to give it this surface, which we're going to feed it, and I'm just going to leave it like that for now. The second class we're going to define is the world. So the world is going to be made up of many countries. Again, going back to defining an init method, and then we're going to start defining some of the methods of the world. So the first one's going to be importing the geodata. So that's the data that we have previously saved. So I'm going to call this define read geodata to none. What we're going to do is go with open, then look for our data. So I think we saved it as country coords.json. And then we're going to store it inside the class. So self.geodata equals json.load f. Okay, we need to use this method in the init. The next thing we can do for rendering the countries is we need to do something about the coordinate data, because the coordinate data is actually in like longitude and latitude, and we would like to kind of project it XY typical kind of map. To do that, we're going to have to define the dimensions of this map. So this is going to be the map width and the map height. So I'm going to store these here. I'm also going to do map height as well. I did a quick Google, and it seems like a kind of typical ratio between width and height for maps is the width being 2.05 times greater than the height. So that's what I'm going to do, 2.05 here, multiplied by 4,000. The 4,000 is arbitrary. It just needs to be the same for both width and height. The larger this value is, the kind of more zoomed in our map is going to look. So I'm just going to leave it like that. Okay, the next method we're going to be creating in the world is a method for creating country classes using this geodata. So we're going to call this def create countries self, and we are going to return a dictionary object. So I'm going to initialize an empty dictionary here. I'm then going to iterate through the geodata, which is also a dictionary. So I can do it like this. So for each item in this dictionary, we have the name of the country and also the coordinate list. I'm going to create a new list of coordinates because, as I said before, we're going to have to transform longitude and latitude into kind of typical map coordinates. So to do this, we're going to iterate through the longitude and latitude. So we're going to write to the following transformation. So x equals self.map.width divided by 360 multiplied by 180 plus the first coordinate position. And very similarly for the y, we're going to take the map height, divide by 180, multiplied by 90 minus the second coordinate position. And then we're going to append these new x and y into this xy coords list. So it goes like this. I'm going to store it in a vector 2, so that's x and y. Then finally, I'm going to take this dictionary. The key is going to be the name of the country, and I'm going to create a new country class. I'm going to give it the name, which is from the geodata, and also the XY coords that we've just created, and finally returning this countries. So we can also use that inside the init. So we can say self.countries equals self.create countries. And finally, with the world, because we're exposing the world class in the game class, we're going to give it a draw method, which is also going to take a screen, a surface, and here we're going to iterate through all of the countries, so the countries that we've just created. Because it's a dictionary, we're going to just take the values, and we're going to do country.draw and pass it the screen. Now that we've done that, we can return to our country class and actually write something that is going to render something to the screen inside the draw method. Because what we're working with is a list of coordinates, we want to draw polygons. So I'm going to start off by doing pg.draw polygon. First argument is the screen. Second argument is the color. I'm going for a slightly bluish color here that I thought looked quite good. Next, we're going to give it the points. So we could just put self.chords here, and that would be fine. That would render it. But without a camera, these coordinates are likely going to be off the screen. So what I'm going to do is just apply a temporary offset for now. So this offset will be defined as follows. And we will make an actual camera in the future. This is just because I'm aware that the episode is getting on, and I kind of want to just finish it up here for now. So, whoops. Okay, so we are iterating through the coordinates and we're applying an offset, and this is going to be where the polygon will be rendered. I'm also going to draw a second polygon, but this one being just the outline of the country, so the actual boundaries. I'm going to make this polygon white. It's going to have the same coordinate positions. Only other thing is we're just going to make the width just 1 pixel, just to represent a boundary. Now that this is done, we can return to the game class. We can import the world class that we have just created. We're going to put self.world equals world. Don't need any arguments. No, it's empty. And in the draw method, we can do self.world.draw, and we're going to give it the screen that's inside the game class. Okay, now that we've done that, we can return to main and we can run it. And now we see a map of Europe. So this has worked well. So basically we are plotting all of these boundary positions that define the boundaries between countries. As you can see, it's not quite perfect. For example, we're missing Northern Ireland. That's because of the logic that we did at the start about multi-polygons. So because Northern Ireland is part of the United Kingdom, but we're only taking one landmass per country. That's why Northern Ireland has been excluded. But yeah, this looks like a map of Europe.